Hey, what's up, guys? This is day number 2, lesson 2.2 notes. So day number 2, I'm not sure what day it is. I'm not sure if you all have missed school or anything like that. But as I wrote on the board, I hope follow this. So I'd like, if you miss one day, obviously just try to make sure you're getting through each day of these. So looking at day number 2, lesson 2.2 notes. So what we discussed previously on lesson 2.1 was we talked about the vertex form. F of x is equal to a times x minus h squared plus k. That's what we've kind of discussed in or lesson 1 or 2.1, and that's what we know as vertex form. Something else that we actually talked about was yesterday was we talked about quadratic functions. And when we talked about quadratic functions, I mentioned f of x equals ax squared plus bx plus c. And this is what we know as quadratic form, or the standard form of a quadratic function. So this is kind of more what we would call standard form. Now the unique thing about these two forms is they work hand in hand. So this can be this can be that, either one. I'll kind of show you that. So let's start with one that's in vertex form. And I'll show you the pathway to get to that, which would be f of x, like I'm just going to pick something. F of x equals 2 times x minus 4 squared plus 5. So that is one in vertex form. And then we can kind of, and what we want to do is to take this as standard form. Well, that's actually done very simply, because right here we just have this x minus 4 squared. So we just solve for this right here. So if you think about that, x minus 4, that's multiplying two binomials, which we use FOIL, first, outer, inner, last. So first, x times x is x squared. Outer is negative 4x, x times negative 4. Inner is negative 4 times x, which is also negative 4x. And last would be negative 4 and negative 4. And that would be positive 16. And then we get x squared minus 8x plus 16 from there. So then we take this back over and say f of x is equal to 2 times x squared minus 8x plus 16 plus 5. Okay. Once we then have that, we're going to distribute this 2 to everything. So that would lead us to f of x is equal to 2x squared minus 16x plus 32. So that's 2 times x squared is 2x squared. 2 times negative 8 is negative 16x. And 2 times 16 is 32. And then I drop that plus 5. And then that leads me to f of x is equal to 2x squared minus 16x and then plus 37. And now we have standard form. So that's what we would call standard form. So up here we have vertex form. Here we have standard form. So just in your standard form, and of course, you know, this is a quadratic form just because it has the x squared in it. We can we can reverse that back into a vertex form, and that's kind of what we're going to look at today. But more than just taking it back to vertex form, because vertex form really doesn't really I mean, it can take us it can take us to the graph, but we don't necessarily have to put it completely in this form to find a graph. So first, what I want us to do is just find the vertex of some of these. Now, The vertex form, there's actually a way that I could show you, but I really don't have time here to show you, and it may get very confusing on exactly how to find the vertex of something, or basically how can you get the vertex from this from that. So if you're looking at these forms, we know that vertex form is H and K, but how can that translate to something down here? There is a proof behind that, but I don't want to show you in this video because I think it may be more confusing than helpful. But if you ever need to find the vertex of quadratic standard form, so if you ever need to find the vertex of that form, here it is this, negative b, or negative b over 2a. When I was just taught negative b over 2a. So you never got kind of that negative confused, because keep in mind, if the whole thing's negative, you can put it in the numerator or in the denominator. You can't put it in both because it'd be positive, but you can put it in one. So I've always just been taught to put it with the b, so it's opposite b over 2a. Well, you may be saying, well, what's a and what's b? Well, keep in mind, standard form has a, b, and c. Again, ax plus bx plus c. So a is what's ever in front of x squared. B is whatever's in front of x. So let's jump down to this first one. Let's look at vertex form. And I will add this, that this is actually, when you do this right here, you're only going to get 1 point, and that point is the h coordinate of the h comma k vertex. So this right here is just a way of finding the vertex, but you're only finding the h, and then I'll show you how to find the k. So our goal today is how to find the vertex from a quadratic function. Okay. So if I'm looking at this, negative x squared minus 8x minus 21, I want to follow my formula to find h of this whole hk, or my vertex h comma k. I'm going to do the opposite of b over 2a. Some people find it helpful to say a, b, and c, and that's completely fine if you need to do that. Some people will come to the side and say a is -1 or equal to -1, b is equal to -8, and c is equal to -21. You use whatever you need to do. So opposite b over 2a, opposite of b, well, technically, I can write that as -8 over 2. So that negative, it's the opposite of this, of -8. So it's actually negative. And if I truly substitute 8 in there, it'd look like, or -8 in there, it would look like this, -8. But we know that a -8 is a positive. So it's truly, if you look at b, it's just opposite of b. So whatever b is, it's the opposite of that. So the opposite of -8 is 8, or positive 8. And then 2 times a, which is, in a is -1. And again, you can kind of see here, if you write them out, that's another way to kind of look at it. So I know I have 8 over -2. 8 over -2 is -4. Now what we're looking for is the vertex. So that gives us just the h coordinate. Again, if the vertex is h comma k, that gives us the h. So you could essentially say right now, we are 50% done with the problem. We know the x coordinate of the vertex, but now I need to go find the k coordinate. Well, how I'm going to find the k is actually pretty simple. Because if you think about this being like an xy table, I know what this is. So what is this equation? What is y when x is this? So that means the only thing I'd have to do is to substitute this -4 back into my x's to see what I'd get for the y, and that will give me my vertex. So that looks like this. If I rewrite my original down, y equals -x squared minus 8x minus 21. If I substitute this -4 into each x, it looks like this. Y equals -4 squared minus 8 times -4 minus 21. Again, I subbed this back into the x in order to find the y of this x coordinate -4, and of course we're using from that vertex form h and k, which is the same thing as x and y. So we have y equals negative. That negative is going to stay there, but what's -4 times -4? That's positive 16. So essentially we're saying negative, and you can kind of put parentheses around there if you needed to see that. And then -8 times -4 is positive 32 minus 21. Okay? And then from there, -16 plus 32. -16 plus 32 would be positive 16 minus 21. And then 16 minus 21 would be y equals -5. So when x is -4, and another way I could write that is say like f of -4, because y can be replaced by x. When f is negative, when the x is -4, that's 5. So then therefore my vertex of this would be -4, -5. Okay, give you a second to kind of get that down. And this is my answer. This is all I'm looking for. I'm not looking for anything else except the vertex. I'm not trying to write this in vertex form or anything like that. I could, but once you get the vertex, we'll kind of go to the back, and you'll kind of, or once we get to the back, then you'll kind of see where we're going at with that. So, because our ultimate goal is the ability to graph this, and really we don't need it in vertex form. We really just need the vertex, and we should be good from there. All right, look at number 2. Y equals x squared plus 8x plus 14. So again, h is the opposite of b all over 2a. So the opposite of b would be, right now it's positive 8, so it's going to make it -8 over 2 times a. Keep in mind, a, b, and c. Come to the side and write it if you have to. So I kind of went through that a little fast, but the opposite of b over 2a. Well, b is 8, so the opposite of 8 is -8. Your 2 comes automatically over there with you, and then a is just simply, there's a 1 there, so a times 2 times 1 is just simply 2. So that's actually -8 times 2, and we get another h of -4. So again, -4 is my vertex right here, so I already know I got half my answer. Now I'm going to take this and plug it back into the x. So because what I'm trying to say is when x is -4, what is the y? Because I know that when x is -4, that's part of the vertex. So plug it back in. Y is equal to x squared. I'm going to rewrite this first one down, plus 14. So I say y is equal to -4 squared plus 8 times -4 plus 14. Again, that's just me substituting everything. Now I begin to solve. Well, -4 squared is positive 16 because -4 times -4 is 16. Now you may be saying, whoa, 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 we just had that same one right here and you said it was -16. But keep in mind that had a negative in front of the x squared. Okay? This one didn't have a negative in front of the x squared, but this one did. So just want to make sure that there's no confusion within that. 8 times -4 is a -32. And then we drop our 14. And then it's just math from here. Y equals 16 minus 32 would be -16. Drop that and then drop your 14. And then -16 plus 14 will be -2. So our vertex shall be -4, -2. And you may be saying, hey, what's a way I can check this? Well, the way you can check it would be to go here, go to your calculator, go to y equals. Let me turn up the brightness just a little bit. It may help. Clear this out. Oh, go to y equals and clear that, whatever you may have out. And type that in. Type x squared plus 8x plus 14. And we've gone through the graphing and how to graph stuff. Again, we can graph this. We hit graph. We get this right here. Well, I want to know what the vertex is, so I can actually just hit the left arrow button and I can kind of just find whatever the vertex is there. And as you're seeing it to be -4, -2. And another way you could actually calculate more automatically is hit second, the blue second button, hit calc or trace, which is right here, and saying, what do you want to find? Well, you remember our characteristics of qualities. We have a minimum, so our minimum, and then it's going to ask you 3 questions: left bound, right bound, and guess. I don't even know where I can't find my cursor right now, so I'm just going to hit enter somewhere. That's not right. So I'm going to try it again. Sorry about that. So calculate minimum. I'm like way up there. There we go. Okay, here it comes. Sorry about that. So left bound is on this side. Where is it? Now do a line to the right and then guess, yeah. And as we see here, x is -4, y is -2. And that is what we got here, -4, -2. So an easy way to just check this is to type that into your y equals, graph it, second trace, calculate your minimum 3, and then left bound, just go to the left of your minimum, go to the right of your minimum, and hit enter, and then that'll give you your minimum as well. Again, I want to see the work. When I come back on Monday, I want to see the work, so I don't expect you to come in and be like, well, you said we could do it on the calculator. Make sure I see the work. I think you all understand that. So, or at least most of you understand that. All right, look at number 3. This will be the last one we work like this. So again, when we're trying to find the vertex of this, we want to say H is the opposite of B over 2A. So the opposite of B, so if this is A and this is B and this is C, the opposite of B is -20 and 2 times 2 because A is now 2. So that leads us to -20 over 4. -20 over 4 would be -5. So I just try to make it a habit. I try to make it a habit to say like -5. I go ahead and put that in there as my H just so I don't kind of forget that crucial step. I then rewrite my problem, y equals. This could be f of x equals, so don't freak out if you see f of x because that's completely normal. 2x squared plus 20x plus 47. So I'm just going to punch in -5 into all my x's in order to get the y coordinate of my vertex. So we got y is equal to 2 times -5 squared plus 20 times -5 plus 47. Well, once you get that, you get y equals, I'll give you just a second. I don't mean to go too fast. Sorry if I'm going too fast. 5 squared is actually 25. 20 times -5 is -100. And then drop that 47 down. Well, 2 times 25 is 50. 50 minus 100 plus 47. Well, 50 minus 100 would take us to -50. And then -50 plus 47. So 50 minus 100 is -50. And then plus 47 would take us to -3. Let me double check that. I feel like I'm looking at that totally wrong. Yeah, that's right. Y equals -3. So and Joey, don't be running your mouth. I know you're probably running your mouth at stuff like that, so don't even think about running your mouth. Joey's probably running his mouth in 5th period. Or no, I don't even know what period that is. And whatever Joey and all them, I wonder if Brooke's there today. Not sure what Brooke is. Nicole's probably drawing some art right now. Going to my other class, 1st period, I don't have a clue what's probably going on there. Probably no one's there and everybody's just kind of halfway tired and everybody's just kind of going through the flow there. Then my 4th period, Garrett and Sean are probably trying to like have a riot against the videos and just play ping pong. So there's no telling what's happening right now, but I hope you're sitting down listening, and then I'll shut up and continue. I told you most of you would like this because I don't ramble as much, but I still find a way to ramble, so I do apologize. So hey, make sure you're focused, make sure you're tuned in. All right, let's go to the backside, number 5. Now, so this is where it's saying, all right, now sketch this graph, okay? So if we're sketching this graph, one thing we need to know is the vertex, okay? We really need to know the vertex. So if we're looking for our vertex here, we're going to do what we've been doing, the opposite of B over 2A. So the opposite of B, so this is A, B, and C here. The opposite of B is negative 12 over 2 times A, which is 2. So negative 12 over 4, and that is negative 3. Okay? Or, ooh, see, I just made a mistake. See, that's what I get for talking trash. It's opposite of B, just making sure you're paying attention. That's a positive 12. That's a positive 12, so that would actually be a positive 3. So you just keep you on your toes. That's my goal, keep you on your toes. So H is actually, of the vertex, it's actually going to be 3. So I'm going to say like 3, comma. And then I'm going to follow that same procedure in the beginning. I'm going to plug that back in, plug this 3 back into the X. 2 times 3 squared minus 12 times 3 plus 17. I should have done like a live feed and just recorded this live while I'm in Louisiana. That would have been hilarious. Then so I could have heard you all screaming at me just like, no, that's not right. So we got 3 squared is going to be 9. So 2 times 9 minus 36 because 12 times 3 is 36 plus 17. 2 times 9 is 18. 18 minus 36 plus 17. So 18 minus 36 would be negative 18. And then negative 18 plus 17 is actually going to lead us to negative 1. So our vertex is 3, negative 1. So we go 3, negative 1, and we put a point. Now, keep in mind what we talked about yesterday. We're actually going to draw that axis of symmetry because that can kind of help us graph this a little bit better. So that's my axis of symmetry here. It can be dashed, solid, whatever. And now here, what I want to do here next is, I kind of mentioned this yesterday. This is a shortcut you can kind of follow. Whatever A is right here, you can actually, what you can easily do here is you can go right one or left one and go up whatever A says. If it's negative, you're going to go down. So a shortcut you can always do is to do that. So go right one and up 2, and go left one and up 2. Now, my people who are trying to figure out how to graph this just based on just this right here, as I was going back, remember what I was saying earlier, how this gets to this, and I didn't want to show it to you just on a recording, but this gets to this based on these two things. So you're actually pulling your vertex when you do all this math, when you show all the math out, you're actually pulling your vertex from these two, so you're really just left with this right here. So for my people who are like, man, what's a shortcut way for me to do this? Well, if you just follow, once you get your vertex, which takes care of that and that, then you're just left with 2x squared. So then you would just graph that as if you're just graphing 2x squared. So you know what 2x squared would be. So right 1 up 2, right 2 up 8, left 1 and up 2 and left 2 and up 8. Okay, so that is a possible thing you can do within that. Or what you can do if you don't see that. So basically, once you get your vertex, you can kind of just cover this up right here and just say, okay, what would this graph right here look like from that vertex? You see that? Or you can completely, there's a million ways to do this, but another way, and this may be simpler, is just to type in numbers that, or put in a number that you can get the point of into the whole thing. So like, let's pick 1. And if we get the point for 1, then we're also going to have the point for 5 because the axis of symmetry is the same distance. So let's just put in 1 here. So I'm going to say y equals 2x squared minus 12x plus 17. So that's y equals 2 times 1 squared minus 12 times 1 plus 17. So that's y equals, well, if you keep in mind here, 2 times 1 is 2, or 1 squared is 1, 1 times 2 is 2. Negative 12 times 1 is negative 12, and then plus 17. Well, 2 times negative 12, that'll take us to negative 10, and then negative 10 plus 17 will actually take us to 7. So we basically just made an XY table for it, and what we said was when x is 1 of this whole graph here, when x is 1, what is y? It's 7. So 1, 7. So that kind of backs up that principle of, hey, once you get this, once you get the vertex, that takes care of the B and the C, because the B and the C is what kind of allowed you. You can't see it really, but that's really what allowed you to get the vertex, and then you're just left with this. So that 2 dictates whether the graph is going to stretch or whether it's going to shrink or what it's going to do. Here, it's stretching by 2, okay? So, and then likewise, 1, 2, 1, 2 on this side because we're doing the line of reflection, and then we just kind of have our graph as this. So a bunch of different ways to see this. So I'm not trying to be confusing here, or I'm not trying to make people be like, man, I have no clue what he's talking about. Just keep in mind, you could always do an XY table of this whole thing and get all these points, but that's just, you know, that may take a long time. But just keep in mind, find your vertex. Once you find your vertex, then just find other points that you can find on the graph, or you can just follow this right here. You can just follow whatever that's doing right there. All right, let's look at number 6 real quick. So number 6, y equals negative 2x squared plus 4x minus 4. So if I'm going to solve it, it's opposite of b over 2a for my vertex. Well, this is a, this is b, and this is c here. So opposite of b would be negative 4 over 2 times negative 2 because that's a. Well, negative 4 over negative 4 would actually be 1. So I know 1 is going to be the x-coordinate of my vertex. Now I'm going to plug that back into the original to find the y-coordinate of my vertex, which is what we did on the front side. Math builds on itself. So negative 2 times 1 squared plus 4 times 1 minus 4. So that's just simply going to be negative 2 plus 4 minus 4. Negative 2 plus 4 is 2. 2 minus 4 is negative 2. Or you could have just eliminated that from the start and said it's negative 2. So we now know our vertex is 1, negative 2. 1, 2. So that's our vertex. Let's go ahead and draw our axis of symmetry. I'm going to write vertex right there. Draw our axis of symmetry. Again, you can do dash or solid, whatever you want. As long as you're labeling the axis of symmetry, that's completely fine. Okay, now keep in mind what I told you about A from lesson 2.1 notes. I told you, look, if you go right or left, just whatever that's telling you to do. So if it's negative, you go down. If it's positive, you go up. Because if you put a 1 in here, it's just going to be whatever that is. So watch, you go right 1 and down 2. That's your shortcut to get a couple points. And then same thing here, left 1, go down 2. If you notice over here, from the point, whatever that A tells you to do, go right 1 and then you can go left or right 1, but then whatever that A is, go up or down, whatever it's, if it's positive, go up, if it's negative, go down like we've done here. So the only thing we need to do here is just to find another point. So what I would do is, hey, let's find what 3 would be. Okay, so I can easily just say y equals negative 2x squared plus 4x minus 4. And you can just plug 3 in. Or, like I said, you can basically kind of forget all this and just say, all right, it's negative, which means it's x squared being flipped down. And it's multiplying by 2. So if I should be able to go right 2. It's just like x squared, which is like 1, 1, if we're looking at that xy table. 2, 4, but the difference is you're going to multiply your y-coordinate by 2. So it's actually, so 2x squared would look like this of your xy. It'd look like 1, 2, 2, 8, 3. 3 over here would be normally 9, but now it's going to be 18 over here because you're multiplying the y by 2. But, and I kind of just wrote right in front of that, but y equals negative 2x squared plus 4x minus 4. So if I'm going to actually like if I just want to substitute x in, I can substitute in this 3. So y equals negative 2 times 3 squared plus 4 times 3 minus 4. That will give me my point as well. So there's, again, as I said on the previous problem, a couple different ways to look at it. Y equals negative 2 times 9 plus 12 minus 4. So y equals negative 18 plus 12 minus 4. I know some of you are kind of weird about go ahead and moving that, but negative 18 plus 12, negative 18 plus 12, and then minus 4. And if you had to use a calculator on that, that would be completely fine. But that's going to take us to negative 6 and then minus 4. So y would actually be negative 10. So based on this, based on our original here, when x is 3, y is going to be negative 10. So I got 3, negative 10, which would be here. And then using the axis of symmetry rule, I can go 1, 2, so go 1, 2 there, and then I have my graph. Okay? I hope this is making sense. Going to number 7, last one will work today. X squared minus x, 8x plus 20. So again, define the vertex. So in order to find your vertex, that's your first step. You're going to do opposite of b over 2a. So opposite of b would be positive 8 over 2 times 1 because a is 1 here. So again, that's a, b, and c. So that would be just 8 over 2, which is 4. So I know that's going to be 4. My x-coordinate of my vertex will be 4. Now let's go see what the other one would be by substituting that into the original x. So y equals 4 squared minus 8 times 4 plus 20. Okay? So based on that right there, what we're going to look at is y equals 16 minus 32 plus 20. Oh. 16 minus 32 is going to be negative 16 plus 20. Negative 16 plus 20 will actually be 4. So we have a 4 there. So I have 4. That's my vertex. I'm going to draw my line of symmetry here. I call it line of symmetry, axis of symmetry, whatever. Okay, follow what this says. There's a 1 there, so I can go right 1 up 1, left 1 up 1. And as I just told you, if you want to know how to graph it, cover that up and say x squared. What does the graph of x squared look like? Well, it's right 1 up 1, right 2 up 4. Kind of like what I just talked about right here. It's those coordinates. If you don't feel comfortable with that, that's okay. Punch in another x, like 2. So say y equals x squared minus 8x plus 20. Punch in a 2. Y equals 2 squared minus 8 times 2 plus 20. When you type in a 2, you get 4 minus 16 plus 20. 4 minus 16 is negative 12 plus 20. And that will give you 8. So when it's 2, it's going to be 8, which is that same pattern of left 2 and up 4. So, and then I can follow axis of symmetry and go 1, 2, and then 1, 2 on this side. Therefore, giving me this right here. Hey, and what we'll do with number 9, I actually want you to skip this. Don't worry about it. So don't worry about this. I didn't really give enough room, and I probably don't have quite enough time, and I think this would be more confusing if I taught it on the recording. So I'll hit this up when we get back. And then, so that also means for lesson, what is this, 2.2. So for lesson 2.2 homework, skip number 13 and 14 on the homework. Skip number 13 and 14 on the homework due to us not going over this one. So don't worry about the ones on the homework that look like this. Paper people, you can go ahead and pass out lesson 2.2 homework. Hey, have a great day, guys.